Hi, so we are now doing lecture 7. So far, we've learned the basic terms of the dynamic game. I mean, instead of calling it dynamic games, we are using the term extensive form game. I think I already talked about that. Extensive form game. I mean, compared to the normal form game, um, this extensive form game in which players have an order when they can choose an action. In a normal form game, all players should choose their action simultaneously. Or actually, when I'm playing my action, I should not know what kind of action the other player is playing. Actually, that is also, those have the same meaning. Anyway, but in extensive form game, difference between normal form game is that players in extensive form game has a different timing or time schedule when they can choose their action. That's the main difference between extensive form game and normal form game. We explained the basic terms like an order, nodes, initial nodes, terminal nodes, branch, and so on. We already explained those things. And I think we are here to explain information set. An information set is a set of nodes between which a player cannot distinguish when making a decision. Look at this. Um, in this game tree, you know, here, look at this, the first player. I will call this node, this initial node, A, and I will call this node B, and this node C. Between A, B, C, I mean, once my timing or my order is reached, I mean, we call that as the pass of game. So the pass of game is reached that nodes. The player can know where the player is. If this node is reached, then the player 1 can distinguish between A and B and C. He or she knows that he or she is in the node at the node B. Okay? He or she knows that where he or she is. Because this node is different from A and C. Okay? So those are three different nodes. Or think about that. I will say differently. I mean, if this path is reached, this node is reached, surely, I mean, the game should play this path so that player 1 will have a chance to choose an action at this node, right? Then think about that. And here, if the player 1, first player, has a chance to choose an action at this node, in other sense, what it means, the game should be past this node and branch so that the player 1 can have a chance to play a game. So in other sense, if this node is reached, then the first player knows that previously in the past, this branch were played. I mean, the first player knows that fact. But at this node, the first player knows that the game played this branching node before, right? In other sense, the information the player has at different nodes are different, right? The information here in the initial node is nothing. We usually use this pi symbol to represent that the set is empty, or this is an empty set. Nothing. That, regarding the information that the first player has at this initial node is nothing. Nothing's played here. So that information here is nothing. But here, if the first player can have a chance to play a game between N and S, the first player has an information that, this game is played following this path. Once this node is reached, then the first player knows the fact that the game is played following this path, right? Information levels at these nodes are different, okay? That's the key thing to understand what is an information set. So look at this. Information set again. Information set is a set nodes between which a player cannot distinguish when making a decision. Going back to the previous graph. For example, if these nodes and these nodes are in the same information set, even though what is an information set, if it is in the same information set, the player cannot distinguish where the player is between these nodes and these nodes. Why cannot the player distinguish where the player is between these two nodes? Why? Because the information that the player has at these nodes are the same. Okay? Say differently. If nodes are in the same information set, we don't know, how we define that, but if we say that if these nodes are in the same information set, if I'm representing, for example, with a dot line like this, if these nodes, two nodes are connected with this dot line, it represents that the information that players have at these nodes are the same, so that the player cannot distinguish where the player is located. If I'm connecting these two nodes, what it means, the first player cannot distinguish where the player is between this and this. That is the function of an information set. Okay? Each information set contains decision node for only one of the players. Look at this. Say differently. Here, say that at this node, player can choose another action, M. So at this node, the first player has one more action that the player can choose. Okay, let's say that. Then, now I'm connecting these two nodes with saying that these two nodes are in the same information set. Do you think it makes sense? I don't think so. Even though I arbitrarily connected these two nodes with this dot line to say that these two nodes are in the same information set, it doesn't make sense. Why? When I'm standing here, I can choose 3 actions. But I'm standing here, I can choose 2 actions. What it means, even though at first I didn't know where I am between these two nodes, because the number of actions that I can choose is different between this node and this node, so that as a result, I can distinguish where I am between these two nodes depending on the action that I can choose, so that it doesn't make sense. So if I want to argue that these two nodes are in the same information set, then the kind and the number of actions should be the same between these two nodes, so that I cannot distinguish where I am depending on the kind and the number of the branch or action. Okay? Now, each information set contains decision node for only one of the players. Say differently here, that what I explained here is about the second bullet point. All nodes in a given information set must have the same number of immediate successor. Decision node or terminal should be the same between those two and have the same number and same level here. Same number and same level. Okay, otherwise players can distinguish of them. What is this? Going back to the previous slide. So, the natural question that I have is that, can I connect those two nodes? Player 1 and player 1 doesn't know where I am. It doesn't make sense as well. Because here, I can choose between N and S. If I'm standing here, this is not my turn. So there's nothing I can do. Player 3 will choose. So that even though at first I didn't know where I am, eventually I understand I'm standing here, not here, if I can choose. Okay? Depending on the branch or maybe the action that I can choose from where I am, I can distinguish where I'm standing. So then it doesn't make sense if I'm connecting, nodes of different players. Okay, if I want to make this line like this, dot line, to argue that I don't know where I am. Okay, so that I don't know where I am. It means I don't know. Game is played. Following this path or this path. I don't know if I'm connecting this dot line. To argue that, that node belongs to the same player and also should have the same branch and number and kind. Then I may connect those 2 points depending on the game I want to describe. Okay? Maybe you are not sure about what I'm talking about at this moment, so that I'm giving you an example. If you go further, then you are going to see some game theory. I think I already explained. Some example cases which violate rules like this. It doesn't make sense. I cannot connect these two nodes because the nodes, the owner of these nodes are different. This node belongs to the first player and this node belongs to the second player. Even though I'm connecting those two nodes to argue that, players don't know where they are standing, but it doesn't make sense. Because at this node, the first player can choose something, but if the first player is standing here, first player cannot do anything here. So that, the rational first player will know that where the first player is standing. So it doesn't make sense at all. Likewise, even though these nodes belong to the same players, the second player here, the successor or the branch from that nodes are different. At first, I mean, the second player may not know where the second player is standing here between these two nodes, but here at this node, second player eventually know that, I mean, he or she can choose three kinds of actions, but at this node, the second player can choose just two kinds of action. So that from different nodes, players can choose different actions so that players will know where they are standing. So it doesn't make sense at all. Okay? So I'm giving you one example to make you clear about this. So, by the way, this is what I didn't explain. I mean, it has another rule should follow is this. Think about this person. I mean, there's just one player, player one. And first player choose between left and right, right? And once this node, then player will choose left. Actually, there is a prime here, so L prime and R prime. If this node is choose, then player one will choose L prime and R prime. Okay? I mean, this game tree does not violate the first two rules. I mean, these two nodes belong to the same player, and the successor branch or action that the player can choose are the same at these nodes. So that maybe we can think, okay, I can connect depending on the situation. These two lines, arguing that I don't know where I'm standing. Okay, to say that I can connect those two. Okay, I mean, even though I'm connecting those two nodes, I didn't violate the first two rules. Okay, however, it doesn't make sense at all. Why? I mean, stopping here the video and just try to think why it doesn't make sense at all. Because of what it means, look at this. This is something happened in the past. Okay? Say that I'm standing here, so this is present. Anyway, when the game started here, that was present and that was future. But if once the player choose between N and R, let's say the player one choose L, so the player is taking this path. Now the player is standing here, actually, right? Then this is the past and this is present. So at present, player now can choose between L, I mean here, now choose something here between L prime and R prime. But if I'm connecting those two lines, what it means, okay, now I don't know where I'm standing between here, this node and this node. What it means, I don't know what I chose before. I mean, if I'm eliminating this dot line, then if I'm standing here, what I'm arguing is that I chose L before, now I'm going to choose between L prime and R prime, okay? But once I'm connecting those two nodes, what I'm arguing is that here, I don't know, I chose L before, but I don't know, I mean, where I'm standing. Or I chose the L before, but now I forgot what I chose before, so that I don't remember where I'm standing. Okay? So what it means actually I forgot. If I'm connecting those two lines. Actually, it doesn't make sense because we are dealing, I mean, I know there are people who like that. I understand that. Maybe the old may forget what they chose, right? However, we are not analyzing those type of person because we are interested in selfish and rational. Which means which we call an economic man or women. So once we argue that we are dealing with an economic man, this economic man should be rational. But I think if this person forgot what they chose before, right? Then we think this person is not rational. Maybe this game may be played for a long time, like 4 years. Then I think it's better to start a new game because it's better to think this person forgot long time ago so that we should isolate, this game played before a new game here at present. But if we connect those two games and if we add here that line arguing that this person forgot what happened here before, what it means he just forget what is chose before. So it doesn't make sense. He's not rational. So we don't deal with those kind of things. So then we add a third assumption, calling that perfect recall. What it means, players in the game theory should remember what they has chosen so far. So we cannot add those kind of dot line here. Okay? That is perfect recall. So we assume that people have perfect recall. Now, let's practice. You can remind a coordination game, I think. There are two players, where two players can choose between Starbucks and Coffee Bean. One guy prepare Starbucks and other guys prepare Coffee Beans. In that situation, they choose where to go simultaneously. That was a normal form game. Okay? With extensive form game or dynamic game, we try to illustrate this coordination game as similar as we can. So look at this. So, okay, if we represent that a coordination game, probably we're going to use this kind of table in a normal form game. So Starbucks, Coffee Bean, Starbucks, Coffee Bean, and here is 2, 1. This is the first player. This is the second player. So 0, 0, 0, 0, 0, 1, 2. So when I was describing this coordination game, there were two players which can choose between SNC, and those are the payups. And they choose their strategy simultaneously. That was the basic game setting of this coordination game. Okay. Now let's make a coordination game as similar as we can with using this game theory. First, let's say that if we illustrate this game as a dynamic game, one thing I should say here is that players have an order when they decide an action. Let's say that just the first player start first. So here the first player. So the first player will choose S or C. And now the second player will choose between S and C. If both choose S and S, first player will get 2 and the second player will get 1. SS, if they don't match, they will get nothing. if both choose C, first player will get 1, the second player will get 2. Okay? So now, look at this. Well, this game tree seems to be similar to a normal form game, but one big difference between those two games is that here, the first player, once the first player chose, his or her action, for example, S, then immediately the second player observe that, the second player will observe that and will know where the second player is standing here. So once the first player chose S, then, for example, choose S, the second player knows that, and second player will choose surely this part because the 1 is greater than 0 anyway. Right? So can you see what's different between this game and this game? Here, even though the first player playing choose S, the second player cannot know that, right? So this game here, but the second player will observe that. So this game is different from this game, not the same thing. However, we can make a way that this game is exactly representing this game by connecting those two nodes with this dot line, or by making these two nodes in the same information set. If I'm making these two nodes are in the same information set, what it means, even though the first player choose S or C, the second player cannot know where the second player is standing, right? Or even though the first player will choose S and C, here what the second player knows that, the first player choose between S and C. That's all information that the second player has at this moment. So that, the information that the second player has at this node is just this. The first player chose between S and C. That's it. If I eliminating this dot line, or the nodes are in the different information set, surely the information that the second player will has here will be the first player choose S. Or here the second player choose C. So the information are different. But if by connecting those two lines, no matter which nodes is reached, the information that the second player has is S, C. That's it, right? So the second player, when the second player can choose between S and C, the second player don't know what kind of action was played before, right? Then now compare the game, this coordination game. What the coordination game is describing is that first, those two players are playing this game simultaneously. Or even though they are not playing the game simultaneously, if one player doesn't know what kind of action played by another player when they try to play a game, then that is a situation that a normal form game can describe. But here, look at this normal form game. As a time sense, even though the first player is playing the game, here, when the second player just tried to play his or her action, she or he doesn't know what the first player was playing. So that this is exactly what this game is describing. Maybe we can change the order of the player. Maybe this is the second player, this is the first player. But when they are playing a game, they don't know what kind of action was played, right? If by connecting those two lines, those two nodes by this dot line, so that in some sense this game are the same. I mean, these two games are describing the same situation, right? So that in one sense, we can describe a normal form game with an extensive form game. We don't know it is possible for all situations for all game, but in some cases like this, some game can be transformed to an extensive form game, and these types of extensive form game can be transformed this kind of normal form game. Okay, that's the first thing I'd like to tell you. So I haven't talked about anything, how we can find an equilibrium of this extensive form game. In a normal form game, we can use IESDS or Nash equilibrium, right? However, I didn't tell you anything about the solution concept or the way of finding an equilibrium. But some game can be transformed to a normal form game, right? In this normal form game, if we apply IESDS or Nash equilibrium, we can find an answer or maybe prediction of the game. Okay? I'm going to talk about that part, so I'm stopping here.